discussing a new chapter, chapter 14, statistics. Did you heard about statistics? Okay, for studying this statistics, we want to know first what is meant by a data. I think you studied in the previous year what is meant by data. For that, consider these examples. Runs made by a batsman in the last 10 test matches. Marks scored by the students of your class in mathematics class test. Number of story books read by each of you. The information collected from each of these cases are called data. Okay. Actually, data is the basic unit or important unit of statistics. Every part of our lives utilizes data in one form or the other. So, it becomes essential for us to extract meaningful information from the collected data. So, the extraction of meaningful information from the collected data is actually comes under this branch of mathematics, that is called statistics. Okay, that is statistics deals with collection of data, analysis of data, drawing conclusions about data, all. Okay, now consider these three tasks. Okay, that is you want to find out heights of 20 students of your class. The next task, number of absentees in each day in your class for a month. Okay, third one, heights of 15 plants in or around your school. We want to collect the information on the basis of these three. Okay, there are two methods to collect the data, or there are two types of data, primary data and secondary data. Okay, primary data means the investigator himself or herself collect the data directly from the surroundings. Okay, that is called primary data. The data collected by the investigator himself or herself from the surroundings directly. Okay, and second one, that is secondary data. Secondary data is the data collected by the investigator from any other source. Means the source which already had the information. Okay, that is the investigator is taking the data from any files or any other source which already have the data or from any records like that. The data obtained from such cases are called secondary data. As soon as the investigator collects the data, he wants to express or he wants to present the data. The next step is the presentation of data collected. There are different methods to present the data. Okay, the presentation should be meaningful and should be understand for all the others at a glance. That is very important. Okay, such a type of presentation we need. Now consider this. These are the marks obtained by 10 students in your class in a mathematics class test. Okay, so when we are looking these marks, we want to find out the maximum mark and minimum mark. Okay, so for finding that we want to look one by one marks and find, okay, and search the which is the maximum and which is the minimum, like that. It is actually a raw data. Okay, raw data. That is, we want to find out the maximum and minimum value from this list, and it takes so much time. Okay, but if this data is arranged in ascending or descending order, we can find out the maximum mark and minimum mark easily. Okay, if the same data we are representing like this, that is in the increasing order or in the ascending order, we can see that the minimum mark is 25 and the maximum mark is 95. And you can also find out what is the range of the mark. Range means you want to find out the difference between the highest and lowest mark. Here the range equal to 95 minus 25 equal to 70. Okay, 70 is the range of these 10 marks. Okay, but there is also some problem. What is the problem? If the number of observations, these each numbers we can call it as an observation. Okay. So, if the number of observation is large, is it easy to write in the ascending order and descending order and find the maximum and minimum? It may be time consuming, right? Okay. So, such problems are there. If the observation is large number of observations are there. Consider this data. This is the mark obtained by 30 students in a mathematics class test conducted out of 100 marks. Okay, and you can see that here the mark 36. Okay, how many students scored the mark 36? Can you see? 3 students obtained or scored the mark 36. That is, the frequency of the mark 36 is 3. Now consider the mark 40. How many students scored the mark 40? 4 students scored the mark 40. That is, frequency of the mark 40 is 4. Okay. Here the number of observation is large. So, it will take time to arrange these observations or this data in ascending or descending order. So, we are going to draw the table and represent this data. Okay. So, the marks of the 30 students we can also represent like this using table. First column we want to write the marks. Second column tally marks. And the third column number of students scored that corresponding mark. It means that one student scored the mark 10. One student scored the mark 20. There are 3 students scored the mark 36. There are 4 students scored the mark 40, like that. Okay. And whenever you add all these values of this column, that is frequency, you will get the total number of students. Please add all these values. You will get the total number of students, that is 30. Okay. That is about frequency. This way of representing data is called ungrouped frequency distribution table. Clear? This is ungrouped frequency distribution table. Now consider this data. Actually, this is the mark obtained by 100 students in a mathematics class test, and the mark is out of 100. Okay. And whenever looking this, it is not easy to find out which is the minimum mark, which is the maximum mark, how many students scored 50 mark or 60 mark, like that. Confused, no? Okay, so for representing this large number of data, we are going to make table, or we are condense this data into tabular form for easy understanding. Okay, here the minimum mark among this is 23. And the maximum mark is 98. Using that too, the minimum mark and maximum mark, we are going to make tables. Okay. The mark of that 100 students of mathematics class test can be represented in this way, in this tabular form, in which you can see that we are considering the mark as different groups. The first group is 20 to 29. The second group is 30 to 39, like that. The last group is 90 to 99. And these each group we are called class or class intervals. Okay, so 20 to 29 is a class. 30 to 39 is a class or class interval. And you can see that the width of each class is the same. What is the value? 20 to 29 is a class, is having width 9. Here 30 to 39 is a class which is having width 9. Similarly, 90 to 99 is a class which is having a width 9. So, this is a representation of the data in the tabular form, in which the marks are represented by different classes and each class is having width 9. And from this, you can easily identify how many students scored the mark between 20 to 29. How many students scored marks which lies between 90 to 99. There are 12 students. Okay, I think it will be very easy for you to identify how many students scored like that. Okay, and you please consider each interval. Consider the first interval 20 to 29. Here you can see that the lowest value is 20 and highest value is 29. No? We are calling this 20 as lower class limit and 29 we are calling as upper class limit. Now you please consider the 50 to 59 this class. Here you can see that 50 is the lower class limit and 59 is the upper class limit. Now consider the last class. 90 is the lower class limit and 99 is the upper class limit. And this type of tabular representation of data is called grouped frequency table. We already told you what is ungrouped frequency table. This is different from ungrouped one. This is a grouped frequency distribution table. Is the idea clear, students? Here there are actually 100 students. If you add these all numbers, you will get 100. Since there are total 100 students. Now, 2 new students are coming to this class and they are also attending the examination. And they are getting the marks. First students got the mark 29.5 and the second student got the mark 59.5. Okay. Now can you say in which class actually these 2 students include? Is the first student who got 29.5 include in this class? No. Why? Actually the upper limit or upper class limit of this class is 29. 29.5 is greater than 29, no? So that student cannot be included in this class. Can he include in this class? No. Why? 29.5 is less than 30, no? So he cannot include in this class also. So it is not possible. The same thing will happen for the next student also who scored 59.5. Why it is happening like this? Why such a problem exists? That is because of, you can see that the upper class limit of the first class is 29 and the lower class limit of the second class is 30. These two values are different, you know, 29 and 30. There is a gap between 29 and 30. In the similar way, you can see that there is a gap between 39 and 40. That's why like these problems are arising. Okay. So what we can do? We can make these two values are similar. Then such a problem will not be there. Okay. If these two places are the same value, all values we can include in this table. There will not be a problem. Okay. How we can make these two values are similar? What is the idea? To convert the upper class limit of the first one and the lower class limit of the second class to be equal, what we have to do is, you find the difference between these two numbers. That is difference between this lower class limit of the second class and the upper class limit of the first class. That is difference between 30 and 29. That is 1. You find is half 1 by 2. That is 0.5. Now you want to subtract that value 0.5 from every lower classes. That is, you want to subtract 0.5 from every lower classes. From 20, from 30, from 40, like that. After that, you want to add 0.5 to the upper class limit of every classes. At that time, you will get every classes such that a class is having upper class limited number. The same number will be the lower class limit of the next class. Okay, that is, you want to find out the difference between the upper class limit of the first class and the lower class limit of the second class. Now you want to find its half. Now you want to subtract that value from every lower classes and add that value to every upper classes. Okay, now we can write the next table. Okay. Okay, so we find out the difference between 29 and 30, that is 1. Find its half, 1 by 2, that is 0.5. Now we subtracted 0.5 from every lower classes and add 0.5 to every upper classes. So we got like this. Now you can see that the upper class of the first class and the lower class of the second class are the same. And the upper class of the second class and the lower class of the third class are the same. So now no problem. There will not be a gap between these two. Now also we have some problem. What is the problem? The student who scored 29.5 including which category? First class or second class? There is also a problem. Okay. By convention, 29.5 is included in this category. Okay, 29.5 to 39.5. Not in this category. Okay, in a similar way, the students scored 59.5 come in which class? This class or this one? It is this class only. The student scored the mark 59.5 comes in the class 59.5 to 69.5. Not in this class. Okay, so we want to rearrange here also. Here one more student is coming now. So it become 15. And this class become 18 now. It become 19. Then our data is complete. In this way we are making the lower and upper limit to be equal. Okay, this is about grouped frequency table. So these are the things about grouped frequency table. Okay, clear the idea, students? Okay, in the live class we can do more examples about this grouped frequency table, ungrouped frequency table, range, frequency, etc. Okay, so let's wind up the class. Thank you.